Good day, my people. So today we will consider the concept of mole and Avogadro's number. If you check our previous video, you go see say I don't talk about Avogadro's number. I don't talk about gram atomic weight, and I don't talk about atomic mass unit. So today we go see how the both go work, how we go fit use Avogadro's number and mole together. Now, before we proceed, don't forget to subscribe, don't forget to comment and like our video. Alright, so determine the number of mole of carbon in 1 times 10 raised to minus 6 gram of carbon. Alright, the second question now, calculate the number of atoms of carbon contained in 1 times 10 raised to minus 6 gram of that same carbon. Taking note that the mass number of carbon is what? 12.01 gram. Alright, let's start. For the first one, determine the number of mole of carbon in this. So we remember, say, they don't tell us say 12.01 gram, which is waiting there for 1 mole. You understand? 12.01 gram is the number of gram, the number of gram atomic weight of carbon inside what? Inside 1 mole. If you check our last video, the thing I tell you with that 1 mole of carbon. So from this respect, we go fit check 1 times 10 raised to minus 6 gram. How many will go there inside 1.0 times 10 raised to minus 6 gram. So you go see say I put gram under gram so that mole, where I get here, go there under mole. You understand? So S of carbon. So S mole of carbon. So therefore, at this stage now we go fit cross multiply. So if you cross multiply now, what we go get? This times this and this times this. So we get 12.01 gram times X of what? F of carbon. Let's just say X of carbon. So for the second one, 1 mole of carbon times this, we get 1 mole times what? Times 1 times 10 raised to what? Minus 6. Alright, so at this point now, of course, we go divide by the coefficient of weight of X. So we go say S equal to 1 mole times what? Times 10 raised to minus 6. All over what? All over 12. This please times 10 raised to minus 6. Okay. So 1 times 1 is still 1, so no problem. Times what? Times 12.01 gram. Alright. Hope we are not missing. This is gram. Alright, so you see that gram can now cancel out gram. You understand? Gram can now cancel out gram. So we have mole here. So what we have now is 10 raised to minus 6. 1 times 10 raised to minus 6 divided by 12.01. So using our calculator, 1 times 10 raised to what? Raised to the power of minus 6 divided by what? Divided by 12.01. Alright. We get 1, 2, 3, 4, 5, 6, 7, 8. So 8.3 times. So this is equal to. So this is equal to what? Equal to 8.3 times what? Times 10 raised to what? Raised to minus. Raised to 8. Alright. So we put negative sign. Raised to minus 8. Alright. So this is now what we get. And the unit wey dey here na mole. Of course, you go see say gram don cancel out gram, so na mole remain. Alright, let us check for the second one. Calculate the number of atoms contained in this. Now you go see say the number of mole wey dey here na 8.3 times 10 raised to minus 8 mole. So we go fit decide to use mole in this case since we don get the actual number of mole wey dey inside 1 times 10 raised to minus 6 gram of carbon. You understand? So but if you no still wan use mole, you can still use this one too. You understand? But so I don't know which one you want me to use, but which one will I use now? Let us use this, or let's use this. Anyone we wan use, we go fit use am. So for the second question, we are asked to calculate the number of atoms. So but we know that 12.0 gram, which is 1 mole. You understand? So we can use this, or we can use 1 mole. You understand? 12.0 gram contain how much? Contain 6.02 times 10 raised to what? 23 atoms, according to Avogadro's. Now, wetin the guy tell us? So if this, that means 1 times 10 raised to minus 6 gram will contain how many? Will contain how many atoms? X number of atoms. You understand? So now, like I told you, if you decide to use mole for here, if you decide to use mole, since we don't know, say, it's a 1 times 10 raised to minus 6 gets up to 8.3 moles. 8.3 times 10 raised to minus 8 mole. You understand? So we fit substitute this inside this. Then convert this to 1 mole. Put our 8.3 here. You understand? If you don't understand, if you comment for the video, make I do one for you. Alright. So at this stage now, we will see need to cross multiply. If we cross multiply, we will get waiting. We will get 12 times 10, 12 times x, sorry. 12 times x is equal to what? 1 times 10 raised to power minus 6 gram times what? Times 6.02 times 10 raised to power what? 23 atoms. So if you make S the coefficient of the formula, the standard formula, whereby dividing both sides by the coefficient of x, we will get that x will be waiting, will be 1 times 10 raised to minus 6 gram times what? Times 6.02 times 10 raised to 23 atoms. 23 atoms all over what? All over 12. All over 12 grams. So gram go cancel that gram. Gram go cancel that gram. So what we will get from here now? What we will get? What we will get? If you check your calculator, let us punch. Let us punch the calculator. 1 times 10 raised to the power of minus 6 times 6.02 times 10 raised to the power of what? Raised to the power of 23. Yes. All divided by what? By 12. 12.01. All divided by 12.01. Sorry. 12.01. Since they don't give us for the our formula, to say they don't give us, I'm just used to it, but they don't give us, we're not going to do another thing. So if you punch this, you go get what? We go get 5.01 times 10 raised to 16. We go get that x is equal to what? 5.01 times 10 raised to what? 16 atoms. So now the number of atoms wey dey inside here. Don't forget to subscribe. Tell us what you want me to do for you. Sharp, we go run am. Too much. We'll see you in the next video.